Okay, let's give you guys some more practice. So here, find the derivative of this. Find dy by dx of this. Okay, so press pause and have a go. Okay, so to do this here, natural log both sides. That will then give you this. Okay, and then imagine it as this being a bubble here, and this here being a bubble here. So when you log this side and you log this side, it really boils down to this. Okay, so because when you have log of a over b, that's equal to log of a minus log of b here. So this is log of a minus log of b here. Okay, and then looking at this bit here, you can actually take the power down here. That will give you this. Okay, and then and then now look at this. At the moment, you've got one bubble multiplying with another bubble here, and and imagine the square root as being to the power of a half. Okay, so here, hang on. Here you've got you're logging a product here. So that then boils down to this plus this. Okay, and remember that the square root here is written as to the power of a half. And then and then hang on, and then take this down here. So that will give you this half here. Okay, and then um, hang on, let me think. Oh yeah, and then now use implicit differentiation. So so differentiate this. That will then give you this. Now looking at this, when you differentiate this, it will give you 1 over 4. And because and then you've got to use the chain rule here. You've got to times by 4. Okay, and this half here stays the same. And then when you differentiate this, it will be 1 over this thing here. So it'll be 1 over this thing here. And then you've got to differentiate the bubble itself. So that will give you that will then give you 4x. Okay, and then take away, and then differentiate this. It will be 1 over this thing here. It will be 1 over this thing here. Okay, and then and then this whole thing here simplifies to this. Okay, and now if you want to get y, if you want to get dy by dx on its own, multiply both sides by y. Don't forget, originally our y right at the start, our y was this, and then all we have to do is just get this times this thing here. Okay, if you wanted to, but let's just leave it as it is. Let's just leave it as this whole thing here. Now get a graph plotter, plot in your original y equals blah blah, this thing here, and then plot the derivative, which is this whole thing here, and your graph should look something like this. Okay, so the red line being our original y, and the blue line here is our derivative. So now let's just double check everything. Looking at the red line, you can see it's going downhill, 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 and somewhere in this region here, the derivative should be 0, somewhere around here. Okay, so now looking at the blue line, it's negative because it's going downhill. The red line here is going downhill. So so the blue line is in the negative realm, and you see somewhere in here, somewhere in this region here, the gradient will be 0, and you can see that in the blue line here, it crosses the 0 here. Okay, and then looking at the yeah, and then here you can see it's positive, 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 and then now look at the blue line. You can see it's positive, positive, positive. Now look at the red line here. It's positive, 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 and then it's still positive, but then it gets shallower and shallower and shallower. Now look at the blue line. It's positive, 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 and then it's getting shallower and shallower and shallower. Okay, and then somewhere in this region here, for some reason, it's blank. I'm guessing that this region might not be in our domain. Okay, but something strange is happening in between here. And then looking at the red line again, you can see it's going uphill, positive, 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 positive. Now looking at the blue line, it is hovering above the 0. So it does. So the red line and the blue line correlate with each other. It matches up. Okay, so that's an indication that our derivative here is correct. Okay.